Okay. Okay, so if you could stop sharing your screen. There's some antics going on at my feet. The dogs are with me. Okay, so you've got data. And you're telling it that each of those are dictionaries and so on. So for each of the keys would be for the key in data dot keys, right? You would want to do data k is equal to, that's not right. Let me back up. And here's where you're planting the X and making it a list. And here's where you're planting the Y and making it a list. Okay, so then when you get a little further down into your code and you start reading, all of the structure in your data structure is already present. So for example, way down below, when you have row, then it would be data, row, cohort, and you know that X is already present, and then you can say append, and append what you need to append. Does that help, Kevin?
Yeah, so is X and Y just a placeholder to create the empty list?
Yes, and the reason why I chose the names X and Y is the when you go to make your plot, actually it's going to be a scatter plot, you have to give it X-axis data and Y-axis data. So what I did is I named the two values X and Y, so it'd be pretty clear what they do. So data, and let's say you're plotting the freshman, so it'd be FF X, comma, then data, again for the freshman. Whoops, that make believe that I didn't write that comma. See? So X and Y, I named them X and Y because they're going to be, those values will become the X and Y axis in the graph. But we could have called them apricots and kumquats, be more typing, but less informative. Let me appease my animals for a second. Where it is, I haven't seen it. I can just smell it. Ah, I've been rescued. Okay, Kevin, it looks, your face tells me you have another question.
No, I was just running the program and it's working, so thank you.
You're welcome. Is there any other questions that I can answer about the project? Or the readings, or anything?
What do we turn in?
Just the Python file.
All right.
Okay, so today is a fun day. You do have a project due that maybe that's not so fun. So please, if you have a question about the project, ask it now. There's also the barbecue tonight on Discord. Let me know if you need the invite to our Carthage Computer Science Barbecue Discord channel. And also, there's a reading assigned, chapter 15. And but otherwise, today is going to be about having that contest to see if anyone has created a really cool graph using data from their own major. And the prize is a copy of my best-selling book on the zombie apocalypse through the eyes of a computer scientist. And when I say best-selling, it's the best-selling book I've ever written. So I'm telling the truth. It's the only book I've written. So does anybody want to lead off? Did anyone take up my challenge?
I made a graph.
Okay. Olivia, take it away.
So I didn't really know what kind of like data you wanted us to look at. I'm a math major, by the way. It's running.
Cool.
So I was trying to find like something to do. I didn't know if you wanted us to do something like a project that we would have done in our major or looking at like actual stats from our major. But I ended up looking at test scores for math from elementary school students from 2015.
It sounds promising.
We'll try this again to see if it'll actually show up.
Yeah, it looks like your Replic's stuck. Tuesday's class, be sure to be here because we'll spend Tuesday learning how to install Python natively on your computer. So you can take the skills that you learn in this semester and keep applying them long after you give up on Replit. Hey, good. We saw something for a minute.
Oh, did it disappear? Okay.
Yeah,
Let's try this again.
That's promising.
Oh, I can't see what I'm typing now.
Cool. So you made use of ArgV. Good, good.
And then it's the mean score by grade. I can't.
Did you
See
also calculate the mean score?
No, that was luckily provided in the data.
Ah, okay. So, okay.
It's by grade level. But yeah, that was the
Awesome.
graph I
So-
made.
Okay. So let's see, this one is a bar graph. And so bar graphs are pretty cool. While we're on the subject of bar graphs, it turns out that it's very straightforward to do a stacked bar graph. And by stacked, what I mean is that one set of data is stacked on top of another set of data. Let me draw since I don't have, so Olivia, they got to enter you into the contest. So let's say that you had in your data math scores for, oh, I don't know, native English speakers and English as a second language, and you wanted to draw attention to any differences. So one way of doing that, using what you've already done, is if there was a stacked where this was perhaps grade 4, And then the one on the bottom might be ESL scores, and then added to that. Actually, now that I'm working through this is a terrible demonstration, but I'm stuck with it since I already started. It really doesn't make much sense, but I'll give you the idea of how to do that. And let's say native English speaker. So each bar would be made up of data above and data below. So it turns out that it's pretty easy to make this. It would be 2 calls to bar. And you've got the same x-axis in both. And then you have data 1, and you've got data 2. This is the 2 data sets that you're graphing. And the way to create a stacked bar graph is a keyword beneath, and then you give data 1 beneath equals, sorry. So it's saying that whatever you want on top has the data. So if this is data 2, then you're asking for it to be stacked on top of data 1. And presto changeo, you have a stacked bar graph.
A question.
Yeah.
How am I supposed to interpret this data? Am I supposed to understand that D2 or the taller bar graph is behind the first bar, or is
Well,
this on top of it?
In this case, it is using this capability, it's stacked on top of. So like I said, as I started talking through this was a terrible example because it really doesn't make much sense. So let's say, you see what I got into this is I wanted to avoid yet another example where I use gender, and that's where I got lost. So, so let's say you can bifurcate your data into exactly 2 classes, and you can show the relative difference between the 2 classes within. So let's say here's one and here's the other. The height of both of them gives you the indication of the sum. And the relative difference between the 2 classes, or I should say n classes, is where the dividing lines are. So you're seeing that this is a larger subset of this, let's say grade 4, is a larger subset than this one.
So if we went on using Olivia's graph as an example, then if it was broken down into the classes in each grade level, then the different classes would factor into the entire grade level like this?
Yes, because that's a good example, because you'd be showing the sum, right, of each of. Now, when I said classes, I meant different
I know.
differentiations. When you're saying classes, you're actually referring to 5th grade classes,
Yes.
5-1, 5-2, that sort of thing.
Trying to bring it back to the example we were working with before.
Yes, and good on you for that. And it's a good use of Olivia's model because the total height of each bar will still stay the same, but you're adding a little bit of detail within the bar showing the individual classes. That's a good way of delivering more information from the same picture. Okay, so Olivia, thank you very much. Do you want to talk about how you made, what you were thinking about as you made it? Were there any tricky parts?
Honestly, I think the hardest part was actually finding data. I didn't really know where to look, and I didn't really know what I was looking for. So that
Uh-huh.
was really hard. But for the like the actual like graph, I think trying to figure out what like column like I wanted to use and like how I would convert it to be able to go onto the graph was a little difficult for me. If that
Okay,
makes sense.
it does. But you did a great job. And let's not say but, and you did a great job. Let me show you um, a website that if you're ever in need of data, you can go nuts with this website. It's called Kaggle, kaggle.com. And you can take a look at the data sets. And you can search through this, and who knows what data set you're going to find. Here featured rain in Australia. Okay. How about let's just try searching for data on something. Anybody have an idea of data they'd like to maybe make a graph about? Something from your major. Okay, how about economics? Let's say assets. Look at all this cool stuff. Property sales, Fortune 500 companies in 2017. Let's take a look at that. And it will give you an explorer kind of view of the data that's in this data set. Well, first it's saying that it's one file. Let me make this bigger. One file, and there are 10 columns, and the columns are, nope, that's not telling me what's in them. It's just telling me what kind of columns there are. But over here, let's push on column. And so the columns are rank, company name, number of employees, previous rank, revenues, and then it's free to download. So download the data right there. Okay.
And is that a CSV?
It will be a CSV. Yes. But it wants you to register, and I do have an account. I just don't want to deal with it right now.
Is there a link where we can find this, or do we have to type it separately?
It's kaggle.com. So let me, when you zoom into a window, does that include, that doesn't include the title bar. But so KAGGLE.com. And interestingly, it now, when I first saw this, and the last time I looked, it was only data, but apparently now there's the code. Interesting. So 50,000 public data sets, and these notebooks are online. Hey, guess what? Look what language they're using. Cool, Python. So these notebooks are where you'll find code and data put together into some type of lesson or explanation. I bet we might have some geoscience majors here. So I'll tell you what, how about geographic? And okay, so we'll look at just the data sets. Something topical. So Afghanistan population, this is pretty cool. It's got a lot of stuff. So great website for getting data, especially restricted in subject matter to maybe you need do some research for your major. Okay, or you just need something to impress your friends with. Not that COVID is a subject matter that you should make light of.
Wait, I'm sorry. Was there anything you wanted us to download?
No, I want you to just make a note that this website exists and so that you can use it as a resource in the future.
Okay.
Okay. Do we have somebody else to enter the competition, or will Olivia walk away with the prize?
I made a graph.
Okay, Tori, show us.
So I'm a data science major and I wasn't entirely sure what data to use either. So I just used some data from my data science class.
Good.
It made up data about the cootie virus in different countries. So I made it by the percent of cases each year in each country.
So very, very cool. So you've got the markers on there, and you've got the legend, different colors going on. Very good. So tell us about your process in doing this. How did you find doing it?
Not that great. Mainly because I was really tired, and there was definitely an easier way to do it than the way I did it. But I just found a way that worked and kind of left it at that.
Would you like to go over your code?
Yeah, so I just have a lot of repetitive code.
I
So like I
see.
couldn't figure out how to do each color, so I kind of made each individual graph so that I could change the color of each country. I feel
Okay.
like there's a way to do that, but I didn't know how to.
No, this is okay. Okay. A suggestion that I would have is if, for example, S year and S percent and N year and N percent, if those themselves were in a list, and then you could just have a loop that said for each set of years, for example, do a scatter, and you'd be taking the next set from the list. So here, let me, I'm gonna, if you could stop sharing on your side, let me share the iPad again, and let's take a look at an example. So you have, for example, whoops, that's the wrong tool, S year, right? And what was so that's an X-axis, and what was the Y-axis that goes along with it?
ES percent.
ES?
Oh, S percent. S was
Okay,
the first country started with an S.
S%. Okay, and then so then you did a scatter of that, and then a scatter of, what was the next one?
It was N.
N year, and then N percent. And so you have a whole bunch of lines like this. So what if instead, instead of repeating like that, you could approach it this way. You could say, let's say chart data is equal to a list of S year, S percent, and color. So in our case, the color would be something, whoops, wrong tool. Would be something like this. So there's two, and let's say there's more. So instead of scatter, 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 it would be then, if you had something like this, it would be for CD in chart data. You'd have the PLT dot scatter of CD0, CD1, CD2. See, and now instead of having many, many lines of scatter, 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 you have it all collected into one little loop. So this would be an example of something that programmers and computer scientists love to do, called abstraction. So we've abstracted all these different data sets into a single data structure that's more convenient. Does that make sense, Tori?
Yeah, that does. Thanks.
All right, so let me get rid of this. And okay, and how about another graph?
I have one.
Okay, let me stop sharing.
So I'm a geoscience and GIS major.
Awesome.
So we have plenty of data to use, but this year, obviously, COVID, we've used a lot of data sets that have to do with COVID.
Mhm.
So I chose to do a pie chart, and basically it's just the case percentages by the top 10 counties in Illinois that have the most amount of coronavirus cases. And I thought the pie chart would just be useful in showing how the distribution through each county, and specifically Cook County because it's Chicago. So I think this data is at recent as of like Tuesday afternoon. So Cook County, as of Tuesday afternoon, there were 870,595 total cases in these top 10 counties alone. And Cook County had 483,000 around there. DuPage had 79,010. Will County, 66,632. Lake County, 60,810. Kane County, 51,672. St. Clair, 28,779. Winnebago, 28,631. Madison County, 28,540. McHenry County, 24,919, and Champaign, 18,602.
Okay, now I noticed that this has sort of like a 3D effect. Did you do that?
No, I don't believe so. I just looked up, or I went on the Matplotlib gallery and just found the most basic pie chart there was. So
Uh-huh.
I think it just kind of did that on its own, from what I
Okay.
believe.
Very cool. Can you show us your code?
Oh, yeah. Oops, it's kind of really extended. There we go. I can run it. It's really short. I did not believe that it would be this short, but it ended up being pretty simple.
Are you impressed?
What?
Are you impressed with this expressive power you now have and that it's so short to do?
I know, I was pretty happy that it was that short.
Huh. Say, so look, there's on line 8, second line of line 8, shadow equals true. That's what's giving you the 3D effect.
That's what I thought, because on the gallery, it showed like a sample code, and I was like trying to go through all of it. And I was like, that has to be what it means.
Mm-hmm. And
I could, with the explode, I technically could, like if I did 1, I think DuPage
Oh.
County would then be like really
higher.
like yeah, like it would take up a
Whoa,
chunk.
cool. All
that-
right.
That's another way of just showing like how you can show like a chunk of the chart.
So you notice that DuPage County started at the top and seemed to be going counterclockwise. Yeah, give it another run. Okay,
Oops,
whoops.
there we
Yeah.
go.
So you see how the right-hand side of DuPage County is vertical.
Mhm.
So that's kind of like the start angle. Now take a look at the end of line 8. It says start angle equals
Yeah.
90.
I have that at 90.
Right. So start angle is where the first wedge is going to be aligned with. So it starts out along the x-axis, that's 0, and then goes counterclockwise. So there's the 90.
Mhm. Okay.
Okay. So I wonder, okay, so we know what explode does now. That's pretty cool. And there's a really powerful feature, auto percent. So you didn't even have to generate the percentages.
Not really, no.
Well, good job. Good job. And good job finding related to your major.
Thank you.
Okay, another person?
I have one.
Excellent, go ahead.
I thought that we were supposed to use stew data though, so it's based on that.
Any data you want.
Okay.
Ooh, I'm liking this already.
This is, I took these were the majors in stew data that had the most 4.0s out of all the data.
Mm-hmm.
And then this is the graph for it. Wait. And then I have a little arrow indicating that this was the major with the highest number of 4.0s.
I wonder what major that is. Is that maybe that's criminal? No, that's CJS.
Yeah, I have no idea. CCS.
Okay, talk to us. Tell us what you were thinking about when you did this. What were your challenges?
At first, I plotted all of the majors on the x-axis, but they all kind of got jumbled together. So I just
Yeah.
went through and I looked through because originally I had populated like an entire dictionary, and each of the majors were the keys. And then I did the same thing. It was like if the GPA was 4.0, I set up a counter and it would add to that value. So my original graph was like a bunch of bars and a bunch of mushed up words right here.
Right.
And I went through my dictionary and I just picked out all of the majors that had 9 or more 4.0s, and I just plotted those. So I made I made a dictionary with all of the keys set up already, so I could just make the counter. So for each GPA that had a 4.0 and that was already in the dictionary, it would take the major key and it would add a counter for that. And then I just plotted the values on the y-axis and the keys on the x-axis.
Oh, tell us about line 19. That's pretty cool.
That I was doing the chapter for the Zybooks reading and I saw when they were teaching about it and I was like, oh, I could use that. So it just puts text wherever you specify like the coordinates wise. So I have it over CCS and at a y value of 14, that's where the arrow starts. And then the text itself is a little above it at 16, but in the same like position. And then the arrow properties, this is the color that it is. So I made it to red. And then this is how like distorted it looks. So if I were to make it bigger, it would be like a thicker arrow.
Very cool. You know what? My soul is touched. It looks like people in class have learned. I'm so pleased. Excellent. Wow, excellent. I'm really, really proud of you, everybody. Anyone else?
I'm so sorry that I didn't. I got caught up on, I don't know what data in my major entails.
Okay. What is your major?
Japanese language.
Ah,
So,
okay. Oh, I know. As an applied example, let's take a flyer. Let's just try. Let's go back to Kaggle and see what we can get if we just put in Japan. Okay. Milo, there you go.
okay.
Here's the idea. You can go to Kaggle and do a search on anything and see what comes up.
All right.
So now you could write a report in Japanese on earthquakes and supply all your own pictures.
All my own graphs.
Yeah.
All right. Thank you.
Okay.
Yeah, it's just, I wish I had known about this Kaggle thing.
I wish I
before
had
today.
told you about this. Sorry about that. Okay. All right. Anybody else? Okay, so I don't want to I don't want to be put in a position of judging best graph. So what do you say, everybody? All four contestants get a book. Is that acceptable? Frankly, I have a lot of books on hand. I'm kidding. All four. It's extremely well reviewed. All right, now how am I going to get you the books? That's the issue. Is anyone here a graduate? Is Olivia, Victoria, Sarah, or Ida did I say it right?
Yeah.
Good. Are any of you graduating seniors?
No.
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 Okay, so, all right. Well, I'll figure out a way to get you the books. Are you all on campus at any time?
Yeah.
I am.
Same as well.
Okay, so one idea that comes to mind is I have a mailbox in the mail room in the basement of Lentz. I could probably put books there, and if you drop by and just pick up a book, open it up and see which one is yours. Okay, because I'll autograph each one.
Thank
And I'll
you.
Thank
Keep
you.
that
Thank
book.
you.
You're welcome. Keep that book. When it's made into a major motion picture, you'll have the original book before anybody else. Okay.
Would you want to write for that if that actually happens?
Do I want to what?
Actually, no, scratch that. Would you want to write and do the effects for it?
Well, it would be an easy movie to make. The easy movie to make. So basically, what it's about is a tech entrepreneur retires to the northern Wisconsin because his wife is from northern Wisconsin, and they had a deal where we'll live some years in doing your business, and then we'll switch. We'll do some years doing my business, and so they're up in Wisconsin, and then the world goes to shit. Starting at UW in Madison, where a researcher who is a real researcher was trying to figure out how to make the 1918 flu more contagious, which there really is a researcher at UW-Madison trying to make the 1918 flu more contagious. And what's funny about that is, there's a lot of funny things about that, is this super secret lab, which potentially could end humanity, is in basically a strip mall on the west side of town. not exactly a strip mall, but it's basically as secure as a strip mall. So the end of the world comes about based upon a $15 an hour lab assistant making a mistake. So yay, go UW-Madison. Okay. All right, so Tuesday, we're going to be making a pivot. So on Tuesday, be prepared with your computer with some space made on your computer. You might need a number of gigabytes, so you're going to have to delete some My Little Pony videos or maybe a video game or some music. Make sure you have a few gigabytes of space available on your computer, and we're going to install Python environment on your computers so that you can keep using the lessons you've learned after the end of the semester. Okay, so that's what we'll be doing on Tuesday. Now, once we have Python running on your local computers, there's some technologies we can take advantage of which simply don't work on Replit. So for example, then we'll start to be able to play with pictures. Maybe we can make a GIF maker. And by the way, it is GIF, it's not GIF. Okay? Does anybody have any confusion about that?
Hey, if
It
I
is-
unplug my headphone jack, can you say that again so my roommate can hear it?
Yeah, sure.
Hey, Lena.
Okay, it is definitely GIF, not GIF.
According to my computer science professor,
Yeah, and not only that.
it's not GIF, it's GIF.
The inventor of that file format was asked to give Milo, are we still on speaker?
No, but I can put it on speaker.
Yeah, go ahead. For the benefit of your roommate.
Okay.
The inventor of the file format was asked to give a keynote address at a conference, and his entire slide deck was one slide, and it said, it's GIF, as in Jiffy, not GIF, as in gift. That was his entire slide set.
How was this guy not sued for copyright by the peanut butter company, though?
Well, I don't know. Maybe they think it's a piece of advertising for them. Okay. So yeah, GIF files first came out on CompuServe. CompuServe was a early bulletin board system, massively large. Interestingly, the computers ran on, what was the name of the tax preparation company? What's the name of that tax preparer that advertises and, come on.
TurboTax?
No, not before TurboTax. Let me look it up.
Intuit?
No, before Intuit. Let's see, tax preparer. They're still around. Not TurboTax. Interesting. For some reason, the letter A, H&R Block. I was going to say the letter A comes to mind. No, it's H&R Block. So isn't it cool that H&R Block, who would have thought that H&R Block would have a key role in the formation of social networks? So CompuServe was one of the first, and it was on H&R Block's computers. Interestingly enough. So, okay, so we'll be able to do things like use pictures and which we can't do now because Replit is pretty weak on dealing with pictures. As you see, all the problems that we've had. Okay, so does anybody have any questions for review or any other purpose? Okay, so on Tuesday, be ready to install Python on your own local machine, okay? Okay, then I'll see you on Tuesday. Have a wonderful weekend. If you have any questions about your particular project, I'll stay right now. Otherwise, you can sign off.
Thank you. Bye.
Thank you.
Thank
Bye.
you.
I have a question about the way that saving things onto your computer works. Because I know at some point I was doing a project with one of my other Japanese student friends, and completely unrelated. But she told me and the other person we were working with that I noticed I have 2 local drives on my computer. She was like, yeah, put them in the one that's labeled D, not local disk or whatever.
Okay,
I don't know. And I don't know how to do that.
okay. I can help you with that if you share your entire desktop, not a window.
Fair enough.
So one of your choices is to share the whole desktop.
Okay.
Oh, and let's stop video recording this. We don't need to do that.
Oh, yes, I would appreciate it. Thank you.
Yeah.